Hey, what's up, fellas? I had to build a deburring machine today, and some of the rules were is I couldn't spend any money except for the motor, and I had one gearbox in mind, but man, was this a battle.
Well, it's nowhere near as loud as the Harbor Freight units. Yep. All right, I tried hooking two different relays up to this thing so I didn't burn this thing up. One of them is a latching relay, which means once you activate it, it stays turned on until it receives another power pulse again. So I'd have to reconfigure this thing to use that. So I decided to hook this thing up, and for whatever reason, it's acting like it don't have enough power to activate. I actually got to hit the trigger, give it a little tap to get it to go up. So something was up with this thing. I can't imagine what's wrong with it. So anyway, I'm going to turn this to 5 seconds. Just so we ain't here all freaking day. I'm going to turn this to 50% for 5. And here we go. I don't like the way it stops. Look at that hard stop. And I don't know how to quit it from doing that. I can't get it to stop doing that. So now I can just set this thing to like run for 2 hours or whatever and go from there. All right, so there's a thermal cutoff somewhere in this motor apparently. It just shuts off for no reason out of nowhere. So I might have to figure that out. One of these little dudes buried inside the winding itself. You can't see it. I can see a wire going in there. It's going to be one of these right here. So we're going to tap into here and remove the thermal cutoff. And we're going to bore some damn cooling holes into the Chinese freaking motor here, because they don't know how to cool stuff off. So yeah, I'm definitely going to be doing that. We're going to be drilling some holes here and some holes in the back of this thing. I could solve all these cooling problems and thermocouple problems with this thing right here. Chop this armature off and maybe turn this piece on the lathe so I can get it in the chuck here. I probably wouldn't even need an alignment shaft. Just put a spring mount on that motor. All right, we've optimized the angle here just a little bit with that little boot. So I could not find the thermal cutoff. The damn thing's like hidden inside the winding, like wrapped inside the top mount. So I've added some cooling holes. And I took off the crap cooling fan. We're gonna try this. I have a better blower I can hook up to it. If I have to hook a leaf blower up to this damn thing to make it work, you better believe I will. That's the next move here. Matter of fact, we've got one sitting right over there, so you may be seeing that. Forced air leaf blower cooling. All right, guys, so here's the patch. This is what we're doing today, damn it. It's unfortunate that the motor wasn't up to the job. I do have way too much in there. I don't know why I don't just take some out. I'm being stubborn and refusing to remove material from the roller, and I don't know why. When I took the stator housing off the motor and gave the armature a turn, it was quite torquey. There was a lot of torque on that little armature, and they don't have much force on them when they're running at that high RPM. So I see why it's getting so hot. I'm gonna make a cowling for this blower. And the thing works great. it'll run forever now with this blower on here to cool it. It's essentially one of these. I'm always using stuff for what you ain't supposed to use it for. That's kind of my thing, I guess, because if you go to buy something that's made specifically for that, they think they're all cool because they have what you want and want to charge you 10 times as much for it. It's a little scratched, but I'm not too worried about that. So I'm definitely happy with the quality of the cleaning. It rounded the edges a little bit on this piece, which I like. Got most of the plasma grit out of those lines. All right, so there it is, guys. I wasn't letting this damn thing beat me. I got a speed controller for my cooling fan, so I'm not just full power. I've built a cowling for this thing, so we've got air going into the back of the motor with some breather holes, and that lets it run 100% duty cycle with this thing completely filled up. I'm going to run this thing till the motor burns up, and then I'm going to hook that drill motor I showed you up to it for speed control. These drill motors are very effective for stuff like this. About 5 years ago, I was in the middle of a hot job, and my motor just failed on me. The centrifugal force switch or whatever it is just broke. That's what's wrong with the motor that's in this lathe. And I couldn't get it fixed. And I needed a motor, and I needed it now. So I grabbed a freaking drill off the shelf and propped this thing on there. And I've had no reason to remove it since. The plan was, yeah, we'll replace the motor when we get time. And this thing ended up outperforming any motor I could have ever hoped for, because now I have speed control on the lathe. Whereas before, you know, a one-phase motor, you can't speed control it. You got to get a 3-phase and do all this crap. And one of those Band-Aids that just held on forever turned into a whisker. Because, as I said in the past, the golden RPM for any tumbling device is about 37 RPMs or so. Anything higher than that, and centrifugal force just sticks it to the wall. That's kind of the problem. But, man, this thing beat me up. It really did. Not being able to find those thermal cutoff fuses. I had 2 relays not work. I don't have time to troubleshoot all that. I probably burn them up in some of my previous experimenting and just forgot. But there it is, fellas. I might do another video of this thing down the road. I regret not having any stainless steel to make this outside piece.